Now, let's discuss how to solve the logarithmic inequality. So, in solving logarithmic inequality, we need to consider this property of logarithmic inequalities. So, first, if your b is greater than to 0 and less than to 1, then x sub 1 is less than to x sub 2, or this x are your power. If and only if log base b of x sub 1 is greater than, so greater than to the value of your log b of x sub 2. So when we have a value of your base in between to 0 to 1, then your x sub 1 is less than to x sub 2. If and only if this is the case. Another property we have, if our base is greater than to 1, then your x sub 1 is less than to x sub 2 if and only if your logarithm is log b of x sub 1 is less than to log b of x sub 2. So they have the same symbols because our base is a positive number and not equal to 1 or greater than to 1. So it's different here because our base is in between to 0 to 1. Those are the properties that we need to consider in solving logarithmic inequalities. So now, let's have examples.
Now, let's have our first example in solving logarithmic inequalities. So we have here log base 3 of 2x minus 1 greater than 2 log base 3 of x plus 2. So our base here is equals to 2. So this is greater than 2, b is greater than to 1. Then we will now follow the second property, which is if b is greater than 1, then your x sub 1 is greater than to your x sub 2 if and only if your log b of x sub 1 is greater than to the log b of your x sub 2. So they have the same symbol. So now here, for our solution, the first step is to make sure that the logarithms are defined. How can we do that? Then, our 2x minus 1, the power of our left side, should be, since it's greater than 0, should be greater than to 0. And the power of our right side, x plus 2, should be also greater than to 0. So this must be satisfied. So our x here, so we have 2x greater than the positive 1, so we have x greater than to 1 half, and we have here x greater than to negative 2. Your x must be, the value of our x must be greater than to 1 half and greater than to negative 2. Of course, if it's greater than to 1 half, totally it means that it's greater than to negative 2. Now, our second step, let's find the value of the x or the solution set in this logarithmic inequality. So we have log base 3 of 2x minus 1 greater than to log 3 of x plus 2. So since we have same basis, same property, same procedure in our logarithmic inequality equations, if we have same basis, we can now get the power. So we have a power here 2x minus 1 greater than 2x plus 2. So let's combine similar terms. So let's transpose positive x to the left side. So we have 2x minus x greater than 2. Let's transpose the constant term to this right side to be combined to this constant. So we have positive 1 plus 2. So 2x minus x. Let's simplify it. We have equals to x is greater than 1 plus 2, that is equals to 3. So the solution set here, we have x greater than 3, or in interval notation, that is positive 3 to positive infinity. So this is the solution set to our logarithmic inequality. So this solution proves that your x is greater than 1/2. So our x is positive 3, which is greater than 1/2, and greater than negative 2 to positive infinity. So that this greater than is up to positive infinity. So this is our solution set. Let's have another example in solving logarithmic inequalities. So we have here given negative 2 less than 2 log x, or the common logarithm of x, less than 2 positive 2. So let's define first the logarithm. So let's make sure we have here the log. So solution. So first, make sure that your logarithm are defined. So we have here the log x, and our x should be greater than 2, 0. Second solution, let's now solve our logarithmic inequality. So we have negative 2 less than log x less than positive 2. So this log x is log base 10 of x. Negative 2 can also be defined with a base 10. So we have log base 10 power of 10 raised to negative 2. So this is equals to negative 2. And our positive 2 can be an exponent of a log, which is equals to log 10 base 10 of 10 raised to 2. This is equals to 2. So simplify, substituting these logarithms, we have log. You can just neglect writing the 10, the base 10. So 10 raised to negative 2 less than 2 log x less than 2 log 10 raised to 2. So now, they have the same bases. We are all in logarithmic form. Let's get the power. So we have 10 raised to negative 2 less than 2x less than 2, 10 raised to 2. And 10 raised to negative 2, this is equals to 1 over 10 raised to 2 less than 2x less than 2, 10 raised to 2, that is 10 times 10 is 100. And 1 over 10 raised to 2, that is 1 over 100 greater than less than 2x less than 2, 100. This is the solution set, or in interval notation, we have from 1 over 100 to 100. So this is the solution set, or the values of our x in this logarithmic inequality. So when we substitute values from 1 over 100 to up to 100 in this logarithmic inequality, it should be a true statement. So that's it for solving logarithmic inequalities.